Hi guys, I'm George Nicolay Lumano from PSIS 1B, and today I'm gonna explain you about fundamental to counting. So I give you a short background about the fundamentals of counting. The fundamentals of counting are a set of rules and strategies used to determine the number of possible outcomes in a given situation. These principles are essential in various fields, including probability, statistics, computer science, and combinatorics. So, why I choose fundamentals of counting? It's basic. The fundamentals of counting provide a solid foundation for understanding more advanced topics in information system. These principles are essential for algorithm analysis, database design, network configuration, cryptography, and probability and statistics. Why fundamentals of counting is important in my course, Information System? Because they have similarities. First, we have algorithm analysis. It determines the number of steps of operation in an algorithm, used to analyze the time complexity and space complexity of algorithms, helping to choose the most efficient algorithm for a given task. Example, calculating the number of comparison in a sorting algorithm. Second, database design. Calculates the number of possible combination of data entries. Helps in estimating the storage requirements, optimizing query performance, and ensuring data integrity. Example, determining the number of possible user roles and permission in a database system. Third, network configurations. It determines the number of possible network topologies and communication pathways. Important for designing scalable and reliable network infrastructures. Example, calculating the number of possible IP address combination in subnet. Fourth, cryptography. It calculates the number of possible encryption keys and combinations, essential for developing secure system and protecting sensitive data from unauthorized access. Example, determining the strength of a password based on the number of possible character combinations. Fifth, probability and statistics. It provides the basis for calculating probabilities in various scenarios, used for data analysis, risk assessment, and decision making. Example, predicting the likelihood of a system failure based on historical data. And lastly, combinatorial optimization. It helps in finding the best possible solution from a set of discrete options, used in resource allocation and scheduling. Example, determining the best arrangement of tasks to minimize processing time. And we have here an example. A web application requires user to create a password. The password policy mandates that the password must be exactly 8 characters long. It must include at least one uppercase letter, one lowercase letter, and one digit. How many possible passwords can be created under their rules? First step, password with only uppercase letters. If the password consists only of uppercase letters, there are 26 options for each position. Total number of such password, 26 of the power 8 is equal to 208,827,064,576. Second step, password with only lowercase letters. If the password consists only of lowercase letters, there are 26 options for each position. Total number of such passwords, 26 of the power of 8 is equal to 208,827,064,576. Third step, password with only digits. If the password consists only of digits, there are 10 options for each position. Total number of such password, 10 to the power of 8, is equal to 100 million. And lastly, apply inclusion-exclusion principle. Total number of invalid password that do not meet the requirements. Password with only uppercase letter plus password with only lowercase letter plus password with only digit. 26 of the power 8 plus 26 of the power 8 plus 10 of the power 8. And we have a 208,827,000,000 and 64,576 plus 208,827,000,000 and 64,576 plus 100 billion. But we're gonna add first the two same value to the total of 417,754,129,000 and 152 plus 100 million. And lastly, let's add the 417,754,129,000 and 152 plus 100 million is equal to 417,854,129,000 and 152. Learning the fundamentals of counting helped me realize how important basic mathematical thinking is in information system. Concepts like permutation and combination show me how to analyze different possibilities, make better decisions, and understand how systems work behind the scene. Even simple counting principles can guide us in planning system features, organizing data, or solving technical problems. This lesson reminded me that information system isn't just about technology, it also relies on clear logic and problem-solving skills that start with the basics. And that's it for today. I hope you enjoy my video. Again, I'm Lumanog George Nicolay from BSIS 1B. Bye-bye!